Hello there, welcome to PreCal Lecture 2.8, where we are going to be dealing with radicals, all right? How to solve for x when we've got radicals involved. All right, so section 2.8.1, we'll call dealing with radicals. All right, let me get a new marker here. Okay, so our first example, let's say we have x is equal to the square root of 15 minus 2x. So we could square both sides to lift the radical. All right, so if we do that, so if you square something that has the square root in it, right, the radical would go away. So x squared is equal to 15 minus 2x. Now let's bring this 15 minus 2x over to the left. So x squared and then plus 2x minus 15 equals 0, right? We're adding 2x to both sides and subtracting 15 from both sides. Now we can try to factor. So we have x, and then probably plus 5 minus 3 would work. So that gives me a positive 2 in the center when I FOIL it back out, and negative 15. So we have two solutions. X is equal to negative 5 and positive 3. But you can't circle that yet because we must check by plugging in to the original equation, because squaring can give extraneous solutions. Okay, so we'll plug back in negative 5 into the original equation. So we have x is equal to the square root of 15 minus 2x. So let's check negative 5. So if I plug that in for x, I've got negative 5 is equal to the square root of 15 minus 2 times negative 5. So negative 5 is equal to the square root of 15 plus 10, so the square root of 25. So negative 5 equals 5. That doesn't work, does it? So not equal. So negative 5 is extraneous. Now you have to show that you checked it. All right, but we can go ahead and cross out negative 5. That's a way you can show me it's extraneous, but you do have to show me this math. So let's check 3. So we have our original equation. X is equal to the square root of 15 minus 2x. So checking 3, I have 3 is equal to the square root of 15 minus 2 times 3. 3 is equal to the square root. 15 minus 6 is 9, so 3 is equal to 3. So 3 checks. So we can circle 3. That's our only solution. Negative 5 is an extraneous solution. Okay, so that was introduced. That extraneous solution was introduced because we squared both sides. So while it is a way to solve a really really good way to solve. It can have an element of danger in it. All right, our next example. And by the way, you're doing this on your own paper. This no pre-printed notes today. So we have x is equal to 3 plus the square root of 3 minus x. Okay, so this is easier to solve. If we isolate the radical to one side. So we really just want the radical by itself on one side. So what we can do is move this 3 to the left, and we have x minus 3 is equal to the square root of 3 minus x. Now when we square both sides, we end up lifting the radical. If you didn't do that and you squared this term, when you FOILed it out, you would end up still with radicals. So we want to square both sides. So when you do that, we have x minus 3 all squared is equal to the square root of 3 minus x all squared. And that makes the radical lift. The square root of something removes the radical. And then I'm going to FOIL this out, the left side. So I have x squared minus 6x plus 9 is equal to 3 minus x. So let's move the 3 and the negative x to the left. I'd have x squared minus 5x. So add an x to both sides, and then subtract 3 from both sides. Minus 6 equals 0. Now that looks pretty factorable. Let's give it a go. Should have x. I'm thinking a minus 3. Oh no, 3 and 2, I can't get that to work. Just eyeballing it. Minus 6 plus 1, I think. So give me x squared minus 6x plus x, negative 5x. There we go. So we have two solutions. X minus 6 equals 0, x is equal to 6, and x is equal to negative 1 for this parenthesis. Negative 1 plus 1 is 0. But we have to check. So first let's check 6. We're going to plug back into the original equation. 6 is equal to 3 plus the square root of 3 minus 6. All right, so when you do that, let's see, minus 5x. Oh, I'm so sorry. This is plus 6. I apologize. I don't edit these videos, so you just have to put up with my mistakes. So go back. Let's go back to here. It's plus 6. If it were minus 6, I had factored it right, but plus 6. So now we've got a minus 3 minus 2. All right, so that's going to give me negative 5 in the middle and positive 6 on the end. So I apologize. So x is equal to 2 and 3. All right, now let's check 2. So back to the original equation. 2 is equal to 3 plus the square root. And what made me look at that when I did 6 is I ended up getting a negative under the radical. I did not expect that. So I went back to double check. Oh, did I factor this right? Did I mess something up? Oh, yeah, I messed up that. I wrote that as minus instead of plus. So there you go. So when I make a mistake, you can learn how I fix the mistake. That can help you either not make it or help you fix it. All right, so the square root of 3 minus 2. So that's 2 is equal to 3 plus 1. 2 does not equal to 4. So 2 is an extraneous solution. So I'm just going to X that one out. We do have to check them both because we can have no solution potentially. So check 3, we would have 3 is equal to 3 plus the square root of 3 minus x, 3 minus 3, and that's just 0. So 3 equals 3, that works every time. So 3 is the solution. All right, so show me your work on the checking, and then you can X out the extraneous one and circle the non-extraneous solution if you have an extraneous solution. All right. So again, you're on your own paper today. So we've got a little bit more to do. Let's look at 2.8.2. And we'll call this solving an equation with rational exponents. All right, barely fit that in. All right, rational is just fractions, right? Okay, let's do an example. So let's say we have 5x minus 2 to the 1/2 is equal to 3x plus 6 to the 1/2. Okay, let's square both sides. All right, if we do that, we've got 5x minus 2 to the 1/2 all squared is equal to 3x plus 6 to the 1/2 all squared. Now when you raise a power to a power, you multiply 1/2 times 2 is 1, so that ends up getting rid of the fractional exponent, and we just have 5x minus 2. Same thing over here, a half raised to the second power, 1/2 times 2 is 1, so 3x plus 6. We are going to have to check the solutions, but this is a really easy linear equation now. So subtract 3 from both sides. Let's move that 3x over here, and you're going to have 2x. Add 2 to both sides. 2x is equal to 8. And x is equal to 4. So we only have one solution to check. Well, let's check it. All right, so I've got 5 times 4 minus 2 to the 1/2 power. So I'm back at the original equation. Is that equal to 3 times 4 plus 6 to the 1/2 power? Well, that's 18 to the 1/2. And 12 plus 6 is 18 to the 1/2. Now, I don't have to go any further. 18 to the 1/2 is equal to the 18 to the 1/2. I don't have to figure out what the square root of 18 is. Doesn't matter. It's something and the same something. If they're equal, that's a good enough of a check, so we can circle x equals 4. All right, outstanding. Okay, last example problem of this lecture. So we've got 2x minus 1 to the 2/3 is equal to x to the 1/3. Now I'm trying to get rid of these fractional exponents. So what could I do to both sides? Well, how about, last time we squared both sides because we had a 2 in the denominator. How about we cube both sides? As long as you do the same thing to both sides, it's legal. But you can't cube one side and square the other side. That's not legal. It's no longer the same equation. All right, so I have 2x minus 1 to the 2/3, and I'm going to cube that. is equal to x to the 1/3. And I'm going to raise that to the third power, so cube that. So 2/3 times 3, the 3's cancel, and I end up with 2x minus 1 all squared. And then 1/3 times 3 is 1, is equal to x. Okay, let's write this out twice. We'll FOIL it out. I could also take the square root of both sides. I think this is easier. So I've got 4x squared. I'm FOILing. Minus 2x, so minus 4x. And then -1 times -1 would be +1 equals x. I want to set that equal to 0, so let's move the x over here. So I've got 4x squared, and that would make it a -5x, right? Because I'm subtracting x from both sides. +1 equals 0. Let's see if we can factor this. So 1 is easy, so I'm going to go ahead and put it in, prime number, 1 and 1. So it's either going to be 4x, 4 and 1, or 2 and 2. So 4 and 1, I think, might give me the -5 I need. If we go minus, that's 4x squared minus x minus 4x would be -5x, and -1 times -1 is +1. So we have 4x minus 1 equals 0, so x is equal to 1/4. Right, move that 1, make it positive, divide both sides by 4, and over on this side, x is equal to 1. So I've got 2 potential solutions. Let's check them both. So let's check 1/4. And we're going to plug back into the original equation. So it would have 2 times 1/4 minus 1 to the 2/3. Does that equal 1/4 to the 1/3? All right, well, that's a half minus, see, 2 times, that's 1/2 minus 1, right? So that's -1/2 to the 2/3. Does that equal 1/4 to the 1/3? Okay, well, -1/2 squared is 1/4. So that's 1/4 to the 1/3. So I square it first and then take the cube root, which is to the 1/3, is equal to 1/4 to the 1/3. So that does check. Let's check 1. This will be easier to check, right? So we've got 2 times 1 minus 1 to the 2/3. Checking is the biggest pain of these problems, is equal to 1 to the 1/3. So that's going to be 1 to the 2/3 is equal to 1 to the 1/3. 1 to the 2/3, that's 1 squared is 1. Take the cube root of 1, it's still 1. Cube root of 1 is 1. So they check. So both answers check. So x is equal to 1/4 and 1. So you have 2 solutions on this one. All right. So the homework is worksheet 2.8. And I'm just glancing at it real quick. There are, you do need to remember to isolate the radical to one side. Remember that. It makes it easier to deal with. And there's 5 problems. And show your checking. So solve for x and then show the checking to get full credit for your homework. All right, that does it for this lecture. I'll talk to you on the next one.